Hello everyone, so this is again Muhammed Aziz with a new session of our Go programming language. So today we are going to check the feature of Go, which is known as Go worker pool. Go worker pool are nothing but just a collection of Go routines which work as a concurrent, which execute as a concurrent operations. So I can give you a lifetime example. For example, you have a kitchen and there you have multiple chefs who are working. So you should use the chef with like more efficiently. So for example, a chef is free, so you can give him a new order to actually cook for that particular order, and when the new order come, so you can just assign that to the other chef, so actually who can start working on that one. Means multiple orders can be executed or can be prepared by multiple chefs, and the other orders which you are keep receiving, you can just pass those orders in the queue, and whenever the chef is getting free, he's going to take that order and start working on that one. So this is the same hierarchy which is basically done by the Go worker pool, and we can assign multiple jobs to Go worker pool to get the better efficiency and get the better improvement in our program. So let's check this with the coding example and see how this will work. Okay, so this is our sample example. Let's create a function first that we will basically pass to our Go worker. I will just go with a very simple example, which is Fibonacci number, which is taking one parameter and returning us back an integer. What it will do, as you know, that if n less than equals 1, return n. Otherwise, you just go with the Fibonacci number and return the last two of Fibonacci's, which is n minus 1 plus n plus 2. So this is the function we have created, which creates a Fibonacci numbers. And let's create a worker right now. The worker function, I can say, is a worker, and this function is going to take two parameters, which will be the two channels. The first is jobs of chan. I can say this is also integer, and the other one is results, and that is also a channel of integer. So this is our worker. Okay, so we don't need to make these two parameters the bidirectional. What we can do, we can basically change, because jobs are the one which we are receiving from the channel, right? So you are not going to send back the jobs, and results are the one which we are sending back to the channel. So it doesn't need to be directional, it can be unidirectional. So we are receiving jobs, doing some work on it, and then what we are going to do, we are sending back the results. So here I will use a loop. I can say for n in range, and it can be range of jobs which we are receiving. And what we need to do, we are just going to sending back the results from Fibonacci number, which is n. So this is our Fibonacci function, which is calculating the Fibonacci number, and then we have created a worker which is basically doing the jobs, as it is receiving the jobs and sending us back the results in a channel. So this is our main program, main function, the main entry point of this program. So let's create here two channels, which will be again jobs, and I will say it is channel of integer, and also results. This will be our channel integer. For now, what I will do, I will give it these two channels as the buffer. Like you can say this is the buffer of 50, and here I can also say 50. You can give any number for this. Is for just for right now. I mean, it doesn't make to be 50 or whatever, 100, 150 or something. But for now, I am going to give them 50, 50, so they can just go and run in a buffer. Okay, so now let's create a worker here, which will be go routine worker. So we have go, and worker is going to take jobs and the second parameter of results, which we have defined above. So now these are the go routines which are working. Let's send some jobs to do. Send some loop of 50 numbers, so it knows that to start something working on that one. So I can say let's start with 0 and I less than equals to 50. I plus, and what I'm going to do here, I'm going to give the jobs. This I is going to give inside the jobs, right? So now this worker will start receiving jobs from here, and start calculating the Fibonacci number from 1 to 50, and it is basically the concurrent operation of the routine which will start working on. So once this will be done, I can say just close the jobs because it will be done for now. And you will see, because I have this buffer channel, it's not going to block on something because it has a capacity to store 50 messages. And now once all the calculations be done, we also need to receive the results and to print it. So for that one, again, we have 0, I can say less than equals to 50, I plus plus here. Instead of I will go with J here to better understanding, because I have used I in on the top loop. And here the results which we are receiving, so I know that we are going to receive 50 results because we are going to send 50 jobs. So 50 jobs we are sending, and we are going to receive 50 results here. I think it will go more than 50 because it's equals to 50, so I will do it like 1. It will create a buffer error. For now we are good now, so print line and whatever the results we are receiving, so just put it in here. This is the way of receiving the results. So let's run this one. Alright, so you see, okay, I just found one issue here. This is going to be a very infinite loop for us for Fibonacci, because it should not be +2, instead -2, and then it will basically go and hit our base class, otherwise not. Okay, so we have Fibonacci sequence function, we have a worker, we have set up 50 jobs to do, and we are receiving 50 results from that channel. And let's run this. So you see, we have started receiving results. The first couple of results are coming very quickly, but now it's, you can see it's coming very slowly and slowly and slowly. If I see my task manager, the performance, so it's taking a lot of things, 63% CPU. If I see the processes, if it can show us somehow somewhere, so we can see a little bit. So go worker XZ is using 23.8% of the CPU to execute all these Fibonacci numbers for us. So here what we can do, some core of my processor are not actually taking that to work. So what I can do here, so here I can create more worker, 2, 3, 4, 5. So I have created 5 workers, means 5 chefs in our kitchen, which are going to give us the Fibonacci number. And let's run this now. So now it's a bit faster, as you can see, is better than before. And if I go to my task manager to see how the processes are running right now, so you can see the go worker is now taking 61%, which was like 23% before. It is taking more cores to implement to work on our given tasks. So this is about the go worker pool. So you can assign the different workers to same jobs, but yes, make sure that the results which you are going to receive will not be in a particular order, because maybe this is doing his job first and then it completes his job first and then came back. I mean, it depends. It will be completely unrandom. It will be completely random results which you will receive. But this is a concept of go worker pool. I give you a real time example and how those are working, and with this small example I hope you understand how these can basically you can utilize in your software and your program. So I hope you like this session. Thank you very much for watching, and I will see you again in our next session. Take care. Bye bye.